This lesson is sort of a general conversation about trigonometry. We're going to be using tangent, sine, and cosine. There might even be some 30, 60, 90 triangles, 45, 45, 90. It's just a general conversation about issues revolving around right triangles. Okay, these first few are really simple. Of course, sine is opposite leg over hypotenuse. So from angle P, opposite is 15, hypotenuse is 17. So 15 over 17. Cosine is adjacent leg over the hypotenuse. From P, that's 8 over 17. Tangent is opposite leg over adjacent leg. From P, opposite is 15, adjacent is 8. Sine, opposite over hypotenuse. From E, that's 8 over 17. Cosine is adjacent over hypotenuse. From E, 15 is adjacent, 17 is hypotenuse. Tangent is opposite leg over adjacent leg. From E, opposite is 8 and adjacent is 15. Okay. Looking at number 3, Amanda and Jerome both use a calculator to find the sine of 46 degrees. Below are their keystrokes and the display of the calculator. So let me do these keystrokes and try to show you. There's an issue that you have to be careful of with your calculator, and I want to demonstrate that with this problem. Now, the problem says we're doing sine of 46. So they typed the sine button and then 4, 6, enter. So let's do the same thing. So let's hit our sine button and then we'll type 4, 6, and then we'll hit enter. So we are getting 0.7193. So 0.7193. Okay, so clearly Jerome is right. So what was the question below? Are there keystrokes? Ms. Dabb marked Amanda's answer incorrect. Explained Amanda's error. So, okay, clearly Amanda is wrong based on the fact that she didn't get the answer that we got. But why? Why is she wrong? Here's the reason why. See in this part of the screen where it says DEG. That stands for degrees. There are two different ways to measure angles. One of them is degrees, and one of them is called radians. And if we go into the mode of your calculator, you can switch back and forth between degrees and radians. See, now we are in radian mode, and which is used very often in advanced classes and calculus. So if you go on in your math career, you will probably deal with radians. So you should be able to switch back and forth, but you have to be careful. This year we are working exclusively with degrees. So if we do sine 46 right now in radian mode, we're going to get 0.9017. Okay, 0.9017. That's what happened to Amanda. Okay, so why is Amanda's answer wrong? Amanda's, whoops, I'm spelling Amanda wrong. So Amanda's calculator was in radian mode when it should have been in degree mode. If you want to be on the safe side, you should always make sure your calculator is in degree mode, just in case the wrong button got hit or something. But I like to reset my calculator before I take a test or do a big assignment. So there are many ways to reset your calculator. if you hit the on button and the clear button at the same time, I can't do that on the screen, that will also reset your calculator. Also, there's a reset button on the back of your calculator. Anyway, notice that if you reset your calculator, it does switch back to degree mode. So that's useful to know. Anyway, moving on. Use either a calculator or a trig ratio table to find the following to 4 decimal places. Yeah, clearly we're going to use the calculator. So sine 18 that's 0.3090. I already forgot. 090. Cosine 64. .4384. Tangent 47. .0724. Okay, that was pretty easy. Solve the right triangles. Nearest tenth. Okay, so these are the good old problems that we always do. If this angle is 20, of course this angle is going to be 70 degrees. How did we get that? We just did 90 minus 20, of course. Okay, if I want to find x, this side over here, well, looking at the 20 that we've got, then and looking at the 5 and looking at the x, the 5 is opposite and the x is adjacent. Opposite leg, adjacent leg. So that's the tangent function. So I would do tangent 20 is equal to opposite over adjacent. The unknown is in the denominator, so we will do our reversal technique. So that's going to give us x equals 5 over tangent 20. If we put this in the calculator, it's 13.7. Okay, if I want to find y, so still using the 20 degrees, of course, but this time I'm doing y, and still have to use the 5. So 5 is opposite. Y is the hypotenuse. Opposite over hypotenuse, that's the sine function. So I'm going to go sine 20 is equal to 5 over y. Reversal, y equals 5 over sine 20. That's 14.6. Okay, number 8. Same type of deal. This time we aren't given either angle, so we are going to have to use inverse trig function. So let's try to find this angle up here. If I do this angle up here, then the 14 and the 25 are adjacent and hypotenuse. Well, guess what? That's the cosine function. So yeah, I need a name for this angle. I think, I'll call this angle A, and I'll call this angle B. So now I can say cosine A is equal to adjacent over hypotenuse, 14 over 25. That means A is equal to the inverse cosine of 14 over 25. And that is 55.9 degrees. Okay, now let's find the other angle. Now, if I firmly believe in this angle, I can just subtract from 90. That would give me 34.1. Now, just in case this answer was wrong, I really would like to double check that by finding this angle another way. So if I wanted to find this angle from the beginning, then I would do this. I would say, look at angle B. From angle B, these two numbers are opposite and hypotenuse. So that would be the sine function. So that would tell me that sine B is equal to 14 over 25. So that means B is going to equal the inverse sine of 14 over 25. And that, in fact, does give me 34.1. So now I can be confident that that is the right answer. So if you use an answer that you already had to find a new answer, you should always double check that by finding that answer directly without using what you had before. We still need to find this side over here that they've called x. But we have two sides given, so let's just do the Pythagorean theorem. Okay, so we're just going to do a squared plus b squared equals c squared. So that's going to be 14 squared plus x squared is equal to 25 squared. So that means x squared is equal to 25 squared minus 14 squared. And of course, I will have to take the square root. In my calculator, that's going to look like this. So I get square root of 429, toggle button, that's 20.7. Okay, so it's 20.7. All right, next page. Oh, words, words. Oh no, I might have to think. No. Let's see. You solve a right triangle, and your finished answers show the angles to be 90, 45, and 46. Is this a reasonable answer? Other than the fact that we know that it would be a 45, 45, 90 triangle, not a 45, 46. If you add up these angles, you get 181. It has to be 180, so that's not reasonable. Number 10, Susan knows the measure of the two acute angles in a right triangle. Is this enough information to determine the lengths of each side of a triangle? Why or why not? No. There's not enough information. Because here's the deal. If you know two angles in a triangle, that makes the triangle similar but not congruent. Remember, for example, say if you knew that this was 20 and this was 70, for example. Now here's another triangle that's similar, okay, but I'm going to make this one smaller. Okay, the triangle is similar, you know, it's the same shape, but I made it smaller, but guess what? This would still be 70 and this would be 20. So just because you know the angles, if you don't know anything else, that just will not be able to tell you what the sides are, because you could have a big triangle with those two angles, or you could have a smaller, similar triangle with those same two angles. So angle only proves that the triangles are similar. They don't have to be the same size, as I just mentioned. So you can't find the side lengths. You know, they're unknown. If they can be big or small, there can't be one side length to find. That's what I mean by that. All right, anyway, moving on to number 11. Dan knows the length of one leg and the hypotenuse of a right triangle. Explain how he can find the measures of each angle and the length of the third side. Okay? So let's do an example. So if he knows a leg, okay, so let's let L be the leg that he knows. And let's let H be the hypotenuse that he knows. Okay? So let's explain how he would find these remaining sides. How can he find the measure of each angle? So, for example, the first angle, we'll call it A. So I'm just going to say, here's how he could find A. In fact, here's how he would find the first angle. From this angle, L is the adjacent leg and H is the hypotenuse. So that's cosine. So he could do cosine A would equal adjacent over hypotenuse. So then that means A would equal the inverse cosine of that leg over the hypotenuse. That's how he could find the first angle. The second angle, let's call that B. Well, he could find B because that would just be 90 minus A. Boom. Now, how could he find the other side, the third side? Whoops. Okay, for the third side, he could just use the Pythagorean Theorem. If we call this third side x, for example, I feel like I should use a different color. If we call this third side x, then we would just do x squared plus L squared is equal to H squared. Subtracting the L squared, that would mean x squared is equal to H squared minus L squared. Then taking the square root of both sides, this third side x would be the square root of H squared minus L squared. Okay, so this, he could find the first angle by using the inverse cosine of the leg over the hypotenuse. You could find the second angle by subtracting that angle, the first angle, from 90. And you could find the third side by taking the square root of the hypotenuse squared minus the leg squared. Okay, number 12. Robbie is flying his kite. His hand is holding a string 4 feet above ground level. The string makes a 55-degree angle. When he has 100 feet of string out, how high is the kite above the ground? Okay, I just threw a triangle on here real quick. Obviously, this drawing is not to scale. His hand is 4 feet above the ground, so just keep in mind that this distance right here is 4 feet. 55 degrees above the horizontal, so this is 55 degrees right there. And 100 feet of string, that means this side is 100 right here. So just making this triangle a little bit bigger so we can see what's going on. Okay, so we've got this right triangle. This is 100. This is 55. I could find this side of the triangle. I'm going to call that x. That would be right here. And I'm going to do that right now. That's opposite over hypotenuse. That's a sine function. So sine of 55 is equal to x over 100. To get x by itself, I need to multiply by 100. All right, so 100 sine 55. So x is 81.9 feet. Okay, so of course we just have to add, if we want to find the height above the ground, we need to add on this extra 4 feet. All right, that goes from here to the ground. Okay, so the total distance, total height of the kite is going to be 81.9 plus 4, which is, of course, is 85.9 feet. Okay, that is the classic problem. We've seen this problem like 4 times in class so far, so please make sure you're comfortable with this type of problem. Number 13. A ramp goes up 1 foot for every 3 feet horizontal distance. This particular ramp goes up a total of 5 feet, which of course means that this would be 15, 3 times 5. Anyway, what is the angle of elevation? I've even got a nice arrow showing you that we're talking about this angle right here. I'm going to call it theta. Very often we use theta to represent angles in higher level math. 5 is opposite, 15 is adjacent. That is the tangent function. So tangent theta will equal 5 over 15, opposite over adjacent. That means theta is going to equal the inverse tangent of 5 over 15. And I can just put that in my calculator. And we find that that angle is 18.4 degrees. Okay. Last problem. Number 14. We had this concert. Some friends sit halfway up the bleachers. These are the bleachers right here. Here's the stage. The angle of depression from your horizontal line is 24 degrees, as shown. Your seat is 45 feet above stage level, so that's like this right here. What is your actual distance d to the stage? So we're just, bottom line, we're trying to find d. Remember your z angles? Watch this. Bam, bam, bam. Z angles, also known as alternate interior angles of parallel lines cut by a transversal. But that's a lot to say. Looking at these angles that are formed by the z, if this is 24, then this will be 24 down here. So keep that in mind. Okay, so since this is 24 degrees down here, let's just focus on that. So I've got the 45, and I've got d that I'm trying to find. From the perspective of the 24, the 45 is opposite, and d, of course, is the hypotenuse. So I've got opposite and hypotenuse. So that's the sine function. So we're going to go sine 24 is equal to opposite over hypotenuse. So 45 over d. The unknown is in the denominator, so let's do our reversal. Okay, so we're going to get that d is equal to 45 over the sine of 24. And that I can just put in my calculator. Okay, so d is equal to 110.6 feet. It does say to the nearest foot, so to the nearest foot, that would be 111 feet. And that's it for this assignment.